Hi, thanks for having me here today. Really excited, even though I have the dreaded after lunch session, so really hope you all aren't falling asleep. And this is actually my second time in India, but my first time in Bangalore, and so I'm really enjoying it. Really excited to be here today. I recently left LinkedIn after 5.5 years. As Divya said, I worked on the iOS app for pretty much four years, and then the LinkedIn Learning app for 1.5 years after that. Working at Hustle right now, which is a messaging platform that is a text messaging solution to phone banking, and works with political campaigns, nonprofits, unions, schools. And I'm also working on an app with some friends on the space of fixing problems with trolls, ruining online discussions. I've spoken a lot about scaling mobile apps in Swift, but I'm not going to talk about any of the things that I just mentioned. Today I'm actually going to talk about Swift and robots, both through the lens of rapid prototyping and also through the lens of educational robotics. So on June 1st this year, right before WWDC, Apple made this really sort of throwaway announcement. They said that their iPad Playgrounds app was now going to support programming a variety of robotic platforms, including the Lego Mindstorms kit. I was really shocked. I couldn't believe it. Lego Mindstorms was actually my sort of gateway drug into really enjoying programming. And I had done a bunch of stuff throughout my the years, both in grad school and also in work. And so I really never expected to see Lego Mindstorms intersect Swift, but here we are. So what does this mean for the field of educational robotics? And on their page, you see a lot of these sort of images of kids playing with different robots and programming with the Playgrounds app. But it's also, Lego Mindstorms is also used, and a lot of these kits are also used in research and in business for rapid prototyping of mobile robots. Really cheap platforms where you can very easily sort of test out different algorithms. So what does this mean for both educational robotics and also for those who do rapid prototyping of mobile robots? And so to answer those two questions, I'm going to sort of go down a trip down memory lane to see how we got here, both with the history of Lego Mindstorms programming environments, robotics programming platforms, and then finally where we are today with Swift Playgrounds also being used as an environment to program robots. So our story actually begins in the 80s. This is Seymour Papert. I think he's a little bit of a hero because he invented both Logo, which is this triangle-based programming language, which was actually my first programming language, and also Lego Mindstorms. And so he became what I think is, he did this sort of legendary collaboration with MIT with their Media Lab and also with Lego. And so in the 88, they announced their first sort of project. It was Lego to Logo. And they marketed only in schools, but students could program the behavior of their Lego constructions, but it still had to be tethered to the computer via a cable. And so you can actually see this is a really sort of early version of the Lego Mindstorms, not the commercial version. And so this was when they started developing this programmable brick. And this, I think, actually really fundamentally changed the industry for educational robotics. So by 1998, they had commercialized the brick. I really like to look at this sort of a evolution of the brick. The yellow one over there, that's the one I sort of grew up on, right? And the programmable brick was a tiny portable computer and embedded inside a traditional Lego brick. And so with the added technology, the brick is now capable of interacting with the physical world through sensors and motors. They have the sensor ports on one side, the motors on the other side. And this allows children to build and program their own robots, other computerized contraptions. And so this tech has been, as I said, used not just for play and by kids and by teenagers, but also as a rapid prototyping tool. So that one and the yellow one, that's the first one, version 1 and 2, basically looks like that. Up there, the NXT, that was the update that came around, I think, somewhere in the early-ish 2000s. And then the EV3 is only a couple years old. This is the one that's supported by the Mindstorms. And there's really been a lot that has happened through the years. Like, for instance, like the EV3 supports like Wi-Fi and stuff. Like, there's sort of been like a lot of like evolution to it. And with the NXT, that was the first one where they sort of open sourced their drivers, though they quickly sort of abandoned them. Okay, so, but that was, I think, a really sort of big moment for them. All right, so how do you program this thing? Once it had a commercial release, it came with a visual programming language. This is a screenshot of one of the versions of them, and it had this sort of like puzzle-like piece analogy. And then they also had another version of it for their educational kits. And this one had a more like circuit thing. They had all these gears, and you could make like slightly more sophisticated programs with this. And again, this sort of makes sense because their like target demographic here was children, and right, and this is sort of a nice, easy intro. But there was, you know, like understandably a lot of limitations, but you could still do some interesting things. For example, this is actually, I think, my second robot. That was in, I think, 10th grade, maybe, grade 10 that I did this. And that was programmed all through like one of their visual programming languages, right? You know, it could react to colors in the environment. And so there was still like a lot of interesting things that you could do, like even as like a teenager with this like limited sort of tool set. However, a lot of people think, thought that this was the only way to program the MISRMs, and that's like simply not true. So one of the earliest ones that I'm at least aware of, there were these two languages called NQC and NXC, so not quite C and not exactly C. NQC was the earlier one, and I got introduced to this in high school again. Our teacher sort of told us about this, and it was basically a subset of C. Not a bad route for a high schooler. I think this example is NQC. NXC was like slightly more sophisticated than that. And you could start to like make more like interesting programs with that. NXC, I think, sort of came about because NQC, again, like someone stopped supporting it at some point, and again, it has a lot of limitations. This is still enough for you to do like real prototyping in the field. I actually used NXC for my master's thesis. So I'll do like a quick synopsis of this, mostly for the example, so I'll carry on this example. And so our lab's research at the time centered around solving robotics problems in a minimalist way. And a lot of robotics actually uses really expensive sensors. For example, like the Google self-driving car uses a LiDAR, and that's like a $70,000 investment, which is a lot of money. And so in robotics, there's a set of algorithms that are called the bug algorithms, and they're supposed to be these simple point robots. They get to like an end goal magically, equipped allegedly with just a touch sensor, but it turns out they make a lot of assumptions. And so I sort of did this like project where I was talking about all the assumptions, and in the end I came up with like, all right, well, if I were designing this, I'd have there be a tower. It would be emitting a signal. The robot would be able to like sense that signal, the intensity of it. And I came up with an algorithm where I could prove that, and also for like asymmetric signals, right? So a little bit more realistic. But I could prove a bunch of things around how I could throw this robot in an unknown environment, and it could still get to the tower. So I came up with all the theories and the algorithms, but you know, in the end of the day, it was still in the field of robotics, and you know, you want to have a demo. It doesn't actually have to be a very like replicable thing because you're in academia, not the real world. And so you really, all you need is a demo that you can record. It just needs to work about like once or twice, which is pretty much what happened to this. But it's fine, that's enough. And so this is actually my robot in grad school. And you can see here I have the robot and I have the tower. I think that those are like concrete bricks and like some like regular bricks that I like covered with duct tape. I don't know, it's really, again, this is academia, so you don't actually have to have something super replicable. But I was still able to like actually code this in NXC. And I like debated a lot about how to sort of include this. It's really long, as you can see, it's super wordy. And so that's sort of one of the problems because NXC had this like history that where it came from C. It was just like super wordy, right? You had to do all of this setup. You had to include all these definitions for every like sensor and motor and stuff. And so it's still like not a really great language to use when you're prototyping. Okay, so in the meantime, there's a bunch of other like languages. So it wasn't just NQC and NXC. There was like Robot Basic, which was a fair enough basic. There was like Lejos, which is like it goes like Lego and Java OS or something like that. Robot C, that was like another C variant. And so there are all of these languages that like people are coming up with. And again, because with the NXT, they had sort of open sourced the drivers, people were able to start to make like other languages to program the robot with. At the same time, we're starting to get more and more robotics ecosystems. And interestingly, a lot of these were around when I made the decision to use Lego Mindstorms to prototype my research. But for the most part, except for the Create, which is a programmable version of the Roomba, a lot of the rest of them are still like pretty pricey platforms. But you're still starting to see like an emergence in the field of all these different robots where you can really like rapidly prototype different ideas instead of like coming up and like building like a custom robot. Now, with many robots means that you're now starting to get like super fractured in the field, right? I just like showed you like 5 or 6 different languages just for the Mindstorms alone. So we started to get a sort of like another wave of things, which is how can we come up with a system where like you don't have to like pick a new like language or platform or environment to program this thing like every single time. And so the two sort of notable ones earlier on, there's Willow Garage, which doesn't exist anymore, but very happily ROS does, Robot Operating System, which is not really sort of an operating system, but it's, I think, more of like a sort of generic way to be able to program many different like platforms and a little bit like hardware agnostic. So we start to see like trying to like abstract away the individual hardware and having something that you can use for many things. And Microsoft Robotics Developer Studio is, again, very similar. And ROS, you know, like it supported like real languages. And so we're also getting away from like the toy languages. So there's another sort of like detour in this, and that's with Mathematica. Yes, that's actually me, and a really ill-advised demo that I did, which is why I've now been scarred from doing demos. In fact, I actually thought about bringing the robot that I programmed in Swift for this, but I'd heard a lot of horror stories about customs in Bangalore. And so I decided to not have my Mindstorms like confiscated at the airport. But this was, again, a very similar, actually, I think, goal to what we see with Swift. And so in 2010, I stumbled into my first job out of grad school, and it was like kind of tailor-made for me, right? And so one of the managers at Wolfram had long wanted to explore connecting Mathematica to robotics kits. And so this project, it ultimately sort of got shut down and then rebirthed into this generic device platform. I learned a lot of great lessons from this, and I think like I really see like the Playgrounds experience is like another thing like that has moved on forward from this. And we got like a lot of we had like a lot of the similar goals to Playgrounds, and so there's a layer of hardware abstraction. And then here is like the really big thing. Mathematica has a lot of built-in tools like image processing, right? And then you could do all these like really great visualization of sensor data and motor data. And so you could connect things, you could see all these great like graphs, et cetera. You could do like really complex libraries because it comes with like all of these functions. And so this is, again, even though the program, like, it's running on a computer, like, controlling the robot, there's still, like, a lot of extra, like, a lot of extra power that you get from that. And so this is actually what iBug looked like in Mathematica, or at least part of it, the going towards infrared light. So we're already on one slide, which is really nice, instead of the giant mess that NXC was. And once we'd gotten what a fairly generic syntax, we also started looking into supporting other programs like the Create, actually, from iRobot. And then with our sites on other platforms, I think like the Now was another one we're thinking about. And if you'd like to see a really entertaining demo, you can go to that YouTube link. That's where we found out that if you don't like basically compile all your code, sometimes your robot will drive off a table in the middle of a demo. That was fine. We had multiple robots. It was all okay. You can actually see it. We give like a long presentation on that. Okay, so Swift playgrounds. Craig Federighi said something super interesting in the news release around this. He said more than 1 million kids and adults around the world are already using the Swift Playgrounds app, which is like a really, really fascinating. Like it's like kind of like giant. To be able to like combine that with also being able to directly control robots, drones, instruments, like that's like really, really incredibly powerful. And how he phrased it was an incredibly exciting and powerful way to learn, and I completely agree. And so the Swift Playgrounds, supports multiple platforms, not just the Mindstorms, but also Parrot's drones, the Sparrow, MeBot, Skoog. Has some amount of a layer of hardware abstraction. You still have to have like individual playground. It sort of has like some sort of hidden like library that it's importing. But there's still like a good amount of hardware abstraction. And at the end of the day, you're still using Swift to code it. And you can also visualize what the sensors are seeing, which is really interesting. So here's me like playing with the like touch sensor here. You can see like the number like switching there, and you can do that for like all of the sensors. You're seeing like exactly what it's doing. Similarly for the motors, you're actually seeing like the values for the motors. Like really interesting there. So as a like fun exercise, I decided to try program iBug in Swift. And again, look, I can fit this in one slide, which is super exciting after the NXC days. And I did this in, I'd want to say like a Sunday afternoon. It was really fast. I think maybe like the night before I played around with playgrounds, with setting it up, with figuring out how to like connect it to the Mindstorms. Then the next day I picked like a really simple like robot design. I built it. I like put in this code and it worked really fast. And this is the robot. I think I might have caught my foot somewhere in there, but this is like the beacon, infrared beacon. It actually comes with that too now. Yeah, there's my foot. And then you can see another one there with it like turning around. And so I don't know if I can like emphasize enough like how much time it took me to do this with NXC like back in grad school. And so to be able to like get this much that quickly is actually like a really interesting thing. Like it takes off so much overhead off like the entire process. So what are the takeaways here? I think this is actually like one of the most understated announcements that they made this year. The visualization from the motor and sensor data is like really fascinating. There are some other sensors they have, like the color sensor, et cetera. The infrared sensor. So the infrared sensor that they gave with the robot was actually really noisy. And that's something that I would not have been able to easily tell without seeing that visualization. But like with it, you can see that it's like clearly, it's like going on like all over the place, right? And so that's like a really useful thing to do when you're trying to prototype, is to actually know how good are these sensors? How good are these beacons, right? Like, is this the reason like my code and et cetera is not working? And so that's, I think, a really large thing. And again, that was one of our like motivations, even with Mathematica, was being able to get that sort of power. The templates are useful, but a little irritating. They sort of pre-fill like the functions that come with the EV3. But you have to like tap into the things. I don't know. It's like clearly made for kids, but it's kind of like annoying to actually code in. And then it's slightly irritating that you're like limited to the iPad. I think they could have very easily extended this to playgrounds on desktop. And it's like unclear to me why that functionality isn't there. And it's also not just a playground that it generates. It's just like storybook like package format. And so those are things where I think I would be like really frustrated if I were doing this with prototyping, but I think maybe like minor things like as far as trade-offs go. So takeaways. This is the most modern language I've ever programmed a robot with, right? I spent a lot of time programming robots, not with that, but also in like C, C++, Mathematica. And like Swift is just like a delight to be able to like program a robot with that. Way easier to understand than many of those other languages. And that means that like these kids could actually have like Swift as their introductory language, which to me is like kind of like mind-blowing, right? Like if you already know this, then you can now start like coding like iOS apps. So as far as I'm concerned, if robots are going to take over, at least program them in a language that doesn't make your eyes bleed. Thanks.